next lesson, which is lesson 5.2, we're going to solve systems of linear equations through substitution. Where we left off last time was solving systems of equations through graphing, which is just not really a great method. Because I think one of the things that you probably thought is, hey, what about if the point is not exactly where integers are? Do I need to start just trying out a bunch of points, a bunch of coordinates? Like if the x value looks like it's 1.5, but that doesn't work. Maybe it's 1 1/3. Maybe it's 1 and 1.4, right? 1 2/5. It gets really messy when we go that way. So, additionally, we're kind of just like guessing at stuff with that guess and check method through graphing. I think the great thing for us to pull out of that lesson is that the result, the solution, is a point. That's what we get from the graphing. But there's a better way to do this. There's a more deductive way to do this. So we're going to solve by substitution. What's great is here, this top equation is already solved for y. So what we can do is where we have y in the other equation, we can actually insert in what this is equal to, which is negative x plus 3. Watch. Instead of 3y plus 5x minus 1, we have 3, and what y really is now is it's going to be negative x plus 3 plus 5x equal to negative 1. Now let's take a look at what we have. Now I have one equation that's in one variable, and we're great at solving these. So let's go ahead and distribute there. Negative 3x, 3 times positive 3 is 9, plus 5x is equal to negative 1. Okay, and we're going to combine our like terms. Negative 3x and 5x is going to be 2x plus 9. It's going to be equal to negative 1 minus 9 minus 9. So 2x is going to be equal to negative 10, and x is going to be equal to negative 5. Great. Now that we have that, we can go ahead and insert that into either equation. I'm going to go ahead and put it into the top one. You see why? It's because now when I put this guy back in, it's going to be kind of one step to evaluate. I'm not going to have to multiply times an integer or anything. So I'm going to, instead of have x, put in negative 5, right? Plus 3. So it's a negative 5. In other words, this is going to be positive 5 plus 3. In other words, y is going to be equal to 8. So we have negative 5, we have 8, and that is our solution, negative 5, 8. All right, next. X minus y is equal to negative 4. 2x plus y is equal to 4. And the issue here is we're going to have to convert one of these because it's not equal to a single individual quantity. So let's go ahead and do that. I'm going to solve this guy at the bottom one for y. I could do this top one for x. I could do the top one for y for that matter. But I want to do this where it's going to be the quickest for us just to have this in one variable here. So I'm going to take this as 2x plus y equaling 4. And it's going to be one step where I'm going to take away 2x from both sides. Y is equal to negative 2x plus 4. Okay, this is my new y. So I'm going to plug it into the other equation that I had here. X minus y equal to negative 4. And when I do that, take a look at what happens. I'm going to have x, right, minus, and then instead of y, I'm going to write what y is equal to, which is negative 2x plus 4. And of course, when we substitute, we're going to try to do so in parentheses whenever possible, because it's going to help us make fewer transposition errors. It's also going to help us keep our signs straight. So we are going to have x, we have minus 2x, which is plus 2x, and we have minus 4, which is negative 4, equal to negative 4. Combine your terms here. Okay, so I'm going to have 3x minus 4 is equal to negative 4. Add 4 to both sides. Uh-oh. Maybe this is a problem. Maybe it's actually something really easy, right? Because it looks like we have it equal to 0. Now we got to remember, how does this work? Can we divide by 0? Is that something that we can do? Or do we divide 0? Now dividing by 0 is going to be undefined, but when we divide 0, that just means it's going to be equal to 0. So x is 0. Wonderful. So I'm going to go back here, take one of these original equations. Actually, I'm going to go take that one that I had engineered up here, where now I have y, which is equal to negative 2 times that 0 plus 4. So y is equal to 0 plus 4, right? 0 times anything is just going to be 0, so y is equal to 4. Great. Now I have an x and I have a y, and my answer is not correct unless I represent it in the form of a coordinate. Because remember what that first lesson was all about. We went through all that pain to make sure that we, for every single one of those problems, we're finding what coordinate was, right? What point it was. We'll make sure that we list this as a coordinate, demonstrating clearly that this is a point. I'm going to do this next problem. Got 2 more problems for us to do here. Just for practice. X is equal to 6y minus 7. And 4x plus y is equal to negative 3. What's great, this guy's already done. I don't actually have to do anything, right? I'm going to take this x right here, bam, throw him right into that x. So I'm going to have 4, and instead of my x, I'm going to write the quantity 6y minus 7, and that's going to be equal to, I'm sorry, not equal to, I have to add y, right? 4 times x plus y equals to negative 3. Distribute my 24y minus 28 plus y equal to negative 3. Combine my terms, I'm going to have 25y minus 28 equals to negative 3. Add 28 to both sides, which is going to give me 25y is equal to negative 3 plus 28 is 25. My y is going to be equal to 1. Take my y, throw them back in up here, right? So let's go ahead and do that. Which gives me x, which is equal to 6 times, and instead of y, my y is now 1 minus 7. So x is equal to 6 minus 7, or x is equal to negative 1. So my coordinates are negative 1, comma 1. Let's do another problem here. I have negative x plus y equal to negative 4. I have 4x minus y equal to 10. Now one of these equations I'm going to need to solve for x or for y. It doesn't really matter which one. And I'm just going to do the top one, because why not? And I'm going to solve this one. Now let's see, which one is going to be better? I could solve it for x. The only problem though is if I solve it for x, if I subtract the y, get the x, negative x by itself, now I have to divide everything by negative 1. There's risk there, right? What if I just forget, or I write something down wrong, and I switch up signs incorrectly? Let's just make life easy on ourselves. Let's make life easier. Why not? Let's go ahead and just solve for y here and get rid of the x, because it's going to be a one-step deal, giving me that y is equal to x minus 4. Beautiful. So now I take this y and I shove it into the other equation. 4x minus, and of course my y now is going to be that quantity x minus 4, right, that we substituted in. It's going to be equal to 10. And take a look at that. That's great. We have one equation that's in one variable. 4x minus x is going to be 3x. Minus 4, which is positive 4, is equal to 10. Minus 4 minus 4. 3x is equal to 6, so x is equal to 2. Take that guy. I'm going to throw him back into that first equation I had. Again, make life easier. Substitute in 2. Doesn't matter, right? Doesn't matter which equation of these first ones, and really these first top two, this and this again are the same. So it didn't really matter which one I put it into. Instead of my x, again, I'm going to have 2. I'm going to use that other color to really show that and highlight that substitution that happened. 2 minus 4 is going to be negative 2, and this is going to be 2 comma negative 2. That's my solution. This is a much superior method for doing word problems, gentlemen. We had one that appeared in the last lesson, and one like this. That was that for the first tour on Monday, the museum sells 4 child and 8 adult tickets for a total of $128. Okay, so for the second tour, the museum sells 6 adult tickets for $72. we're going to find the price of one child ticket and the price of one adult ticket. Okay, so what we're going to say here is that we're going to have two variables. We need to define those. We have X and we have Y. X is going to be number of child tickets. And then Y is going to be the number of adult tickets. Okay, now, sorry, it's not the number, it's the price. Because we already have that quantity, right? Because it was 4 child tickets, or 4X, right? And then when we had 8Y, 8 adult tickets, that's for a total of 128. It's really straightforward. So think about what we have here for that other one. We have 6 times the adults. Remember, adults is going to be Y, so 6Y, and that's going to be 72. Now watch this. If I solve this guy right here for Y very quickly is just going to be, right, 6Y equal to 72, divide both sides by 6. Y is going to be 12. We already know then the adult tickets. Take this guy, throw him in here, and that's going to give me 4X plus 8 times Y, which is 12, is going to be equal to 128. 8 times 12, remember your 12's times tables is 96. It's equal to 128. Subtract 96 from both sides. So 4X is going to be equal to 32, right? 12 minus 9 is 3, 8 minus 6 is 2, and then so X is going to be equal to 8. So what this means, it's going to be $8 per child and $12 per adult. All right, Saintsman, that's all we've got for that lesson. Go ahead and get started. Find your assignment on Canvas, and then if you have any questions, go ahead and email me, and I'm happy to answer. Good luck.